today we're going to look at some examples of sketching secant functions. Oops. All right, so here are some features of our secant function. Y is equal to a secant bx minus c plus d, where the stretching factor is the absolute value of a. The period is 2 pi over the absolute value of b. The domain is the domain is all numbers except c over b plus pi over 2 absolute value b times k, where k is not integers, and this is the domain because this is not equal to this, because these are also the definition of the vertical asymptote. And as you recall, vertical asymptotes are invisible lines that are not real lines on our graph. I know that sounds confusing, but they're just places where our graph gets closer and closer to but never touch. That's why our domain is x is not equal to that. Okay. The range is negative infinity to negative absolute value of a plus d in union with the absolute value of a plus d to infinity. And this is important to help us define relative maximum and minimums for our graph. There are no amplitudes when we're dealing with secant functions. And we know that secant function is an even function because cosine is an even function. I have an extra slide in there, I apologize. All right, so let's go ahead and get started. We're going to graph one period of f of x equals negative 2.5 secant 0.4x. So as you can see already, there is no c value and there is no d value. So let me go ahead and let's write out what we have. So we have a, which is equal to negative 2.5. Our b is equal to 0.4. So that means that we can find our period, and our period is equal to 2 pi over the absolute value of b. So we have 2 pi over 0.4, which is equal to, if you put it in your calculator, you'll see that it's 5 pi. So that means that one full period of this graph is going to go 5 pi 5 pi units long. Couldn't think of how to say that. All right, so next let's talk about our asymptotes. So our asymptotes, we were given a formula, and we can go back to that formula really quick. We have the vertical asymptotes occur at x equals c over b. We don't have a c, so we're going to ignore this part here, because if we don't have a c, that means that this is 0, and 0, we don't need it. So we just have pi over 2 absolute value of b times k, where k is an odd integer. So my first k, I'm going to say is equal to 1. And so I have pi over 2 times 0.4 times 1, right? This is an x value, by the way. And so that's going to give me 1.25 pi, or if you like to keep it in fraction form, we'll do 5 pi over 4. We can also do x, k equals negative 1. So we'll do pi over 2 times 0.4 times negative 1, which is going to give us negative 1.25 pi, or negative 5 pi over 4. Now I can check to see, is this enough? Do I have enough information? Well, we can easily see that if I subtract these two values, 1.25 minus a negative 1.25 is just going to give me it's not going to give me 5 pi. So we need to keep going. We need another one. So let's do k equals 3, because 3 is an odd integer. So we'll have x is equal to pi over 2 times 0.4 times 3 this time. And that's going to give me, when I put it in my calculator, 3.75 pi. And so when I check that from 3.75 minus a negative 1.25 pi, I will get 5 pi. So that means that this will complete one full period of my function. So these are the three asymptotes that I'm going to use when I graph that one period. I'm going to use negative 1.25 pi, 1.25 pi, and 3.75 pi. Now let's find some other values to plot. So I'm going to erase my board. I hope you're writing this down, taking notes. Okay, so we have talked about the relative minimum and the relative maximum for our function, and we know that it will be, for this one, because we don't have a d value, it's just going to be negative, which actually doesn't, well, it's negative absolute value of a, and out to positive absolute value of a, or just a and negative a, one way of thinking about it as well. So our a is negative 2.5, so we can go from negative 2.5 to 2.5. And then when we're talking about minimum and maximum, we're talking about height. So these are our y values. So I need to find out, since these are our relative minimum and maximum values, I'm going to find out my x values. So I'm going to plug it into my y to find out what x would have to equal to. So let's do negative 2.5 first. So we'll say negative 2.5 is equal to negative 2.5 secant of 0.4x. So the first thing I'm going to do is divide both sides by negative 2.5. That goes away. Negative over negative is positive. Same number over same number is just plain old 1. So I get 1 is equal to the secant of 0.4x. So I want to know, what can I multiply by 0.4x so that when I multiply it, my secant gives me 1. Okay, so we're thinking about that, and we're thinking about where is that on our unit circle? Well, if you go back and look on your unit circle, you'll see that when secant of 0 is placed on the unit circle, it equals 1. So I can make x equal to 0. So when I do secant of 0, I get 1. So that means that one of the points that I am going to use would be 0, negative 2.5. So that's going to be a relative minimum or maximum for us. All right, so then another point that we're going to use is, of course, our 2.5. So let's plug in 2.5. So we have 2.5 is equal to negative 2.5 secant 0.4x. So again, I divide both sides by negative 2.5, and I get negative 1 is equal to secant 0.4x. And again, I want a value that's going to give me negative 1. So let's take a look at our unit circle. Please pull out a unit circle, look up a unit circle to see. Okay, so when you looked at your unit circle, you should have seen that at pi, secant is equal to negative 1. So I'm going to take this part here because this is what I want. I want x to equal pi. So how can I make x equal pi? So I am out of space. I'm going to have to do some erasing. So I have 0.4x equal to pi. And this is an equation right now. So I can divide both sides by 0.4. And I get x is equal to 2.5 pi. So that means that my 2 points that I can use are 0 and negative 2.5, and I can use 2.5, 2.5 pi and 2.5. So let's go ahead and start graphing our function. Okay, so I went ahead and started off the drawing. I hope that this looks really sloppy, but I hope this is okay. So I put my asymptotes on here first. So I have my asymptote at negative 1.25 pi, my asymptote at 1.25 pi, and my asymptote at 3.75 pi. Now, I do suggest use a graphing calculator. Please use www.desmos.com, free graphing calculator for you to use, okay? You can check your work. But this is just a hand sketch, and so hand sketches will not be perfect. So please stop judging me. I'm just joking. All right, so now I put my relative minimum and maximum, and now I just need to decide which direction that I go in. And I've already decided, I already know, because I already went ahead and plugged in a few values, and that's all you really need to do is say, well, if I plug in a value of x, let's say for example, x that's in between -125 and 1.25, which direction am I going in? Am I going below this -2.5 or above it? It's going below it, so this is the direction of this one here. And then for this one, it's going above it. So here is one full period of our secant graph. And I hope that this helps.